by Pani. Here we are discussing about intermediate second year AP CBSE 12th class. We are in that 5th chapter, continuity and differentiability. So today we will discuss minimum 10 questions from this topic. Dear students, let us have a discussion. The question continuity and differential. First, the first exercise completely belongs to continuity concept. So first, minimum definition. What is continuity? A function f of x is said to be continuous. A function f of x is said to be continuous at x is equal to a, then limit x tends to a, f of x is equal to f of a. Another definition also we have. What is that another definition? Limit x tends to a, f of x, when it will be exist. Limit x tends to a minus f of x is equal to limit x tends to a plus f of x, left limit, right limit, and limit value f of a. Whenever these three are equal, then f of x is continuous at x is equal to a. Okay, dear students. But throughout this exercise, this one and this one, first 10 questions according to my knowledge, we will approach the first definition itself. Okay. We will move to the first question. Prove that the function f of x equal to 5x minus 3 is continuous at x is equal to 0. So first, given function step by step. Given f of x simply equal to 5x minus 3. So at x is equal to 0, they are asking no. So find out, now calculate f of 0. So wherever x is there, replace with 0. 5 into 0 minus 3, which is equal to minus 3. So f of 0 is equal to minus 3. Keep it as equation number 1. Next, f of a completed. Next, this one you can calculate. Now consider limit x tends to 0. At what value it is continuous, they are asking to prove. That we can take as a limit. Limit x tends to 0, f of x. So limit x tends to 0. What is f of x? It is given 5x minus 3. So x is equal to 0, substitute. 5 into 0 minus 3, which is equal to minus 3. So therefore, from 1 and 2, we conclude that from 1 and 2, limit x tends to 0, f of x is equal to minus 3 is equal to f of 0 only, no? So it is in the form of limit x tends to a, f of x equal to f of a, then it is continuous at x is equal to a. Therefore, f of x is continuous. F of x is continuous at x is equal to 0. Hence, proved. So they are asking to prove this result. We proved, dear students. So next, similarly, the question, same procedure we have to follow. Given function f of x is equal to 5x minus 3. At what value they are asking to prove it is continuous? X is equal to minus 3, no? So f of minus 3 is equal to 5 into minus 3 minus 3, which is equal to minus 15 minus 3 minus 18. You keep it as equation number 1. Now consider limit x tends to minus 3, f of x is equal to limit x tends to minus 3, f of x is what here? 5x minus 3. So wherever x is there, replace with minus 3. 5 into minus 3 minus 3. So minus 15 minus 3, which is equal to minus 18. So from 1 and 2, limit x tends to minus 3 f of x is equal to f of minus 3, minus 18 value minus 3. Therefore, f of x is continuous. F of x is continuous at x is equal to minus 3. Hence, proved. We will move to the next question, dear students. Here the question is prove that f of x same value, but the thing is continuous at x is equal to 5. So given function, given f of x equal to 5x minus 3. So at x is equal to a means 5. So calculate f of 5. X is equal to 5, substitute. 5 into 5 minus 3, which is equal to 25 minus 3, which is equal to 22. Keep that equation number 1. Now consider limit x tends to 5, f of x, limit x tends to 5, f of x means 5x minus 3. X is equal to 5, substitute in this. 5 into 5 minus 3. So which is equal to 25 minus 3, 22. From 1 and 2, we get or we conclude limit x tends to 5, f of x is equal to f of 5. So both values are same. Therefore, f of x is continuous at x is equal to 5. Hence, proved. So the first 3 questions, at some point they are asking to prove the function is continuous. Question number 4, once you observe that this is also similar kind of question, but the way is different. So given function f of x is equal to 2x square minus 1. At x is equal to 3, they are asking to examine. So f of 3 calculate. X is equal to 3, substitute in this. 2 into 3 square minus 1. 9 into 2, 18 minus 1, which is equal to 17. Okay. Equation number 1. Now, limit x tends to 3 f of x, which is equal to limit x tends to 3 2x square minus 1. X is equal to 3, substitute. 2 into 3 square minus 1. So 2 into 9 minus 1, 18 minus 1, which is equal to 17, equation number 2. After that, from 1 and 2, limit x tends to 3, f of x is equal to f of 3. Hence, f of x is continuous at x is equal to 3. They are asking to find whether it is continuous or not. Examine means we decided that it is continuous. We proved, dear students. Next, from question number 5 onwards, examine the following. Question number 5 onwards. For all, one statement is there. Examine the following functions. The following functions. Examine the following functions for continuity. For continuity. So question number 5, f of x is equal to x minus 5. They did not given any point. So whenever they did not given any point, let us consider, let x is equal to c be any point. That means C belongs to R. Therefore, f of C find out. C minus 5, equation number 1. Now, calculate limit x tends to C f of x. Limit LIT or LIM. X tends to C. F of x means x minus 5. So wherever x is there, replace with c. C minus 5. So from 1 and 2, we have limit x tends to c f of x is equal to f of c. Therefore, it is the definition of continuity at x is equal to c. No? Therefore, f of x is continuous at x is equal to c, where c belongs to real numbers. That means that only meaning. For all real numbers of c, wherever it is. Okay, dear students. Question number 5. 5 is over 6. In question number 6, the function f of x is given as 1 by x minus 5. First, they provided x is not equal to 5. So, how to proceed to solve these type of problems? First, f of x is defined when x is not equal to 5. Why? Because it is a rational function, f of x by g of x form. F of x is defined when x minus 5 is not equal to 0. That implies that x is not equal to 5. Let x is equal to c but not equal to 5 be any point on the real number line. That means c belongs to R. So now calculating f of c value. 1 by c minus 5, equation number 1. Now consider limit x tends to c, f of x. Limit x tends to c, f of x means 1 by x minus 5. X is equal to c, substitute 1 by c minus 5, equation number 2. From 1 and 2, we have limit x tends to c f of x is equal to f of c. Okay, dear students, this is the way we can. Therefore, f of x is continuous at x is equal to c but not equal to 5. That is, how can we write is c belongs to R. Except 5, remaining c belongs to R. We can write like this also, another way or another representation. F of x is continuous at x is equal to c in R minus 5. Except 5 number, remaining it will be defined. Okay, dear students. Yeah, those who are watching first time, please like and share if it reaches to more students. That is my intention to tell that. Next, question number 7. The question number 7 function is f of x is equal to x square minus 25 divided by x plus 5, provided that x is not equal to minus 5. See, what are the steps we need to consider? Even if you want to simplify, here only you can simplify and write it, nothing will happen. Let x is equal to c be any point on the real number line on the R other than minus 5. So except c value minus 5 it will be. Okay, dear students. Whatever they mention here, that value. Now calculate f of c. So wherever x is there, replace with c. C square minus 25 by c plus 5. C square minus 25 can be written as c minus 5 into c plus 5 divided by c plus 5. C plus 5 get cancelled, c minus 5. So f of c is equal to c minus 5. Keep it as equation number 1. Next, consider limit x tends to c f of x. So limit x tends to c, f of x means x square minus 25 by x plus 5. Even here we can, here only you can simplify. After that you can do that. Limit x tends to c, x minus 5 into x plus 5 divided by x plus 5. So we can cancel them. The rest of the terms, limit x tends to c, x minus 5. So wherever x is there, replace with c, c minus 5. Equation number 2. From 1 and 2, we conclude that we have limit x tends to c, x tends to c f of x is equal to f of c. So f of c value and this function value both are same. Therefore, f of x is continuous on r minus minus 5. Why? Because except that value, since it is in the denominator rational function, except minus 5, it will be defined as students. R minus. Okay, let us move to the question number 8. This question number 8 is the given function f of x is equal to mod x minus 5. See, mod x minus 5 we can write it as two ways. So given function f of x is equal to mod x minus 5 is equal to x minus 5 if x minus 5 is greater than or equal to 0. This is equal to minus of x minus 5 if x minus 5 less than 0. If it is less than 0, we are taking as this one. Greater than or equal to 0, we are taking as like this. Check the continuity at the turning point. Here it is given as 5 now. So clearly they mentioned the conditions. So x minus 5 is greater than means it indicates x is greater than or equal to 5. It indicates x is less than 5. So at x is equal to 5, we need to verify the continuity. Okay, dear students. Here, whenever conditions are there, we need to go for this definition. Second definition, dear students, this one. So first, we have to calculate the value f of 5. F of 5 is equal to, are able to see, dear students? Yes, you can. At x is equal to 5, x is equal to 5, substitute in this. Mod 5 minus 5, which is equal to 0. Keep that equation number 1. Next, right hand limit, that means RHL, right hand limit. At x is equal to 5, we can calculate. Limit extends to 5 plus f of x. The meaning of extends to 5 plus is x is greater than 5. When x is greater than 5, mod x minus 5 value is what? X minus 5, dear students. Limit extends to 5 plus f of x value is x minus 5. So x is equal to 5, substitute 5 minus 5, 0. Equation number 2. Next, left hand limit LHL at x is equal to 5. Limit extends to 5 minus f of x is equal to, limit extends to 5 minus. Extends to 5 minus means x is less than 5. When x is less than 5, mod x minus 5, we can write it as minus of x minus 5. So minus of x minus 5. Now x is equal to 5, substitute minus 0. So anyway, 0 it is. Equation number 3. From 1, 2 and 3, from equation 1, 2 and 3, we conclude that what happens? Limit extends to 5 plus f of x is equal to limit extends to 5 minus f of x, which is also equal to f of 5. Therefore, f of x is continuous. F of x is continuous at x is equal to 5. Okay, dear students. At x is equal to 5, the function f of x is continuous. Exactly, and it is a linear. It is a linear function anyway. It is continuous at anywhere, any point. But according to this function, we can. Okay, dear students, I hope you understand. We'll move on to the next set of questions. Next question number 9. Sorry. Prove that, question number 9. Prove that the function f of x is equal to x power n is continuous at x is equal to n where n is positive integer. So they are asking to prove the function is continuous at x is equal to n. So what we have to do generally, given f of x is equal to x power n. Okay. Later at x is equal to n they are asking now. Now find f of n is equal to n power n. Equation number 1. F of n is equal to n power n, dear students. Now limit x tends to n, f of x is equal to limit x tends to n, f of x is x power n. So x is equal to n, substitute n power n will come. So from 1 and 2, from equation 1 and equation 2, we conclude that limit x tends to n, f of x is equal to f of n. Therefore, f of x is continuous at x is equal to n. At f of x is equal to n. Next we will move to question number 10, dear students. What is the question number 10? Discuss discuss the continuity of the function f of x equal to sin x plus cos x. This is the question, dear students. Discuss the continuity means we need to give the answer. So what we have to do to solve this type of problems? They did not given any condition. Given f of x is equal to sin x plus cos x. Let x is equal to c belongs to R, be any point. So find out f of c. So it will be sin c plus cos c. Equation number 1, dear students. So after that, now consider limit x tends to c f of x. So limit x tends to c. What is f of x here, dear students? Sin x plus cos x. So wherever x is there, replace with c, sin c plus cos c. Equation number 2. From 1 and 2, this is the limit x tends to c f of x. From 1 and 2, we have limit x tends to c f of x is equal to f of c This is the way we can conclude, dear students. That's all. Therefore, f of x is continuous. F of x is continuous. at x is equal to c belongs to R. Otherwise, left right continuity also we can do, but everywhere it is continuous. Even sin x plus cos x, sin x minus cos x, all these functions are continuous, dear students. You can proceed in that way. Okay? The rest of the questions we'll do in the tomorrow's class. We'll start the second bit. Thank you for your support. I'm going to end the session. Thank you all.